Now we're going to be moving on to our next session of talks, which is going to focus on remote learning with lab experiences. We're going to have three speakers today, Dr. Julian Yamamura, Dr. Margot Vijant, and Dr. Mark Miller. And Anne-Marie Thomas, Dr. Anne-Marie Thomas will be moderating the Q&A here at the end of this session. So if we want to go ahead with Julian kicking this off, the screen is yours. Go for it.
All right. So what I wanted to talk about today is kind of reflecting on a year of adapting, assessing all the changes we make, and then refining. So we've been making these little incremental changes, more specifically to the lab that we teach. So let me kind of go into the next slide, which is just a basic 4 things I want to talk about today. So the first one is I teach a construction materials lab. Traditionally, it's in person. So I want to give you kind of a view into what that looks like. And then once you get that point, we'll kind of show you how we transitioned it to a remote lab experience due to the pandemic. And while we're kind of talking about the remote lab experience, we'll talk about some of these incremental changes that we made. And the nice thing about this course is that it's taught to different cohorts every quarter. We're on a quarter system, so we're doing it in fall, winter with a kind of a different point of view for different majors. It's mainly intended for civil engineers, but in winter we have construction management students, different department that kind of also have a different focus, but the lab is relatively kind of similar. And then we have offered another one in spring. So we've had this opportunity to make these incremental changes. And then the third thing we'll talk about is what are the difference that both instructional teams point of view on in-person and remote labs, and then more importantly to the student perspective. And then we'll kind of end it with a short discussion of some of the long and short-term changes that we're going to be making to our lab curriculum as we move on. So the in-person lab experience, so the course is called CEE 337. It's a construction materials course. The course is 2 hours of lectures twice a week, and then we also have a lab element on selected weeks. We have about 6 lab sessions, and each of these lab sessions are about 2 hours long. And one of the main objectives, since we're talking really about lab experience here in this session, at least for our class, these are the objectives. So one, obviously we have some learning objectives that has to do with construction materials. We talk about asphalt, steel, aluminum, wood, concrete, some of the more common building materials that we use in civil engineering. So that's one obvious kind of learning objective. There's another part, which is there's a lecture component, right? We talk a lot. There's interactions, but it's the lab sessions that really allow the students to kind of connect with that content in a little bit of a different way. Going on here, somebody was mentioning about soft skills earlier. Coming from the industry, this is something that I and the instructional team, we really try to work on kind of fostering and promoting soft skills. So teamwork and activity management in a traditional in-person lab, this is relatively an important thing that we kind of keep an eye on. And then the last thing that objective-wise is really coursework to industry work. We have this role here of trying to close this gap between kind of the students and the industry, and a lab session is a great way to kind of relate not only the content of the course, but also to give them a glimpse of how things might be done out in the field or out in the industry. So moving on, this is the first thing that most of the students will do is they'll go into a classroom. And one thing to kind of take note here in the in-person lab is we have limited seating. We've got 4 rows, and each row can accommodate 6 students, so 24 students per lab. Anymore, we just don't have enough seats. And then as I'll show you in the next slide, our lab space is also very limited. Lots of moving parts. There are some labor work that's going on. So in general, there's just a limitation of how many people and students we can enroll in our classes. And it's really because of the lab side of things. And also this classroom time here. I'm going to be talking more about kind of production rate, if you will, with teaching. And about 30% of a lab is usually spent in this classroom in the beginning, kind of debriefing the students, making sure everybody prepared, and so on. And then usually comes the most exciting part for most of the students, which is the actual lab experience. So after they transition and listen to the TAs or myself kind of talk about the task at hand, I simplify it to make it, break it, and write about it. But really what's going on here is they get to design an experiment. And what you're seeing here on the upper left is students designing their own concrete mixture. They get to make it, not only design it, but they get to make it. And then there's some procedures that we can follow, and then we can test some of these samples that we're building, which we call break it. A lot of the tests are destructive. A lot of people tend to enjoy that, as you can see here. And then, of course, that's data collection right there, right? We can figure out how strong concrete is, how strong our materials perform in certain ways. And then it kind of follows a traditional laboratory experiment where you've collected data, and now we can kind of on our own time, our students' own time, they can write about it and through lab reports and interactions and presentations and so on. So make it, break it, and write about it is kind of the in-person lab experience. Now, when we had to transition to remote labs, we wanted to we knew two things. We want all the lab content to be disseminated via online and remote technology. Our campus was already using Zoom to an extent, so we just had a campus-wide adoption of Zoom and some other remote teaching technologies. And the other thing that we also knew in the teaching team here was that it's an opportunity to deliver basically a new type of active learning content. What we didn't want to do was essentially say, okay, well, we can't really do hands-on. The lab is now closed. So let's just go ahead and give them the data part. So the make it and break it part kind of is gone now, and we will just do, going back to this, just the write about it part. And that might be a great mode too. It just totally depends on how much time you have, right? So we had some time to prepare here. So we wanted to figure out how to kind of convert some of the hands-on experience to more of an active learning content. So what you see here, traditionally what students do, they're testing concrete here, just the consistency of the concrete on the left-hand side. So students are getting some kind of like a sensory feedback. That's really kind of hard to teach remotely, right? They actually get to feel what the concrete feels like, what happens when you put too much water in the mixes, things like that. But then if you look at the image on the right-hand side, that's how we kind of transitioned it over, is still doing those same experiences and activities and experiments, but we end up, I do it or the TAs do it in a safe manner where we kind of videotape everything and allow them to kind of watch it. That alone isn't very appealing because it's just kind of another form of lecture, if you will. So we decided to kind of adopt a hybrid asynchronous and synchronous lab approach. So the asynchronous part, as we were just talking about, there's a set of videos that we pre-recorded just so they can take a look at what the lab feels like, looks like, all the equipment. They get the scale and the magnitude of how big certain objects are and the materials that they're testing. But we still wanted we wanted to live stream the lab sessions. We did not want to lose that kind of spontaneous teaching ability. So we have a synchronous part where we were live streaming. So myself and one or two of the other TAs, they felt safe. We went into the lab and we would conduct certain tests in a live fashion. And what we kind of thought about is, these phones, we all have smartphones, GoPros and action cameras are pretty ubiquitous modern tech. You can kind of go to any stores now and it's affordable. So we decided to, rather than having the students all kind of come in because that was unsafe, we would kind of position smartphones and cameras at various angles of certain equipment. And that way the students can be looking at, gauges. They can be looking at the actual material changing over time. And what really happens there is that was as close as we can do at that time to, get them into the lab. So they were actually recording live data through various phone. And we would just spotlight certain videos to bring it into light so they can kind of write down the values. And just to kind of give you an idea what that felt like, hopefully this works. And I'm going to go ahead and play it. It's a pretty fast time lapse, but you can see here there's a piece of metal that's in this machine that's stretching. It's a tension test. And as we're stretching this piece of metal, the TA here is yelling out the load numbers that it's associated with. So essentially the students are, writing all these values down as we're testing it live, and eventually they'll even see the necking and the breaking of the sample. So this is one of those tests where you don't really, the sensory part of it, sensory feedback, I thought wasn't very important there. A lot of it was just visual anyways. So these types of experiments we thought lend itself very nicely to more of a live streaming capability in the labs. So moving on, some incremental changes that we made after doing the first iteration of this was it was getting kind of tiring for us. We kind of adopted the in-person model. So we were doing 3 remote lab sessions. We were still doing it live stream, and what we kind of came up with is, we can actually just do this once, and we can just let as many people into that one lab session. So that was one of the major changes we made, is we increased student capacity for 1 or 2 lab sessions, and what that allowed us to do is we can totally get rid of 1 lab session or 2 of them, and it freed up some time for the instructional team there. Other things that we decided to do due to that extra additional time that we had, we started including more critical thinking discussions. Breakout rooms, we were getting more and more experience as the rest of the world was with online teaching, so we decided to use breakout rooms in various ways. So this is just a photo here that you see. Just by sheer chance, we were watching TV and I saw a commercial about, I think it was Ford, it was like a SLAM campaign. About how one truck was more resilient than the other, and the whole commercial was about dropping a toolbox on the back of the bed, and one truck, as you can see here, getting a penetration, the other one didn't. And I thought that was a great opportunity. These are actually the same material that we're learning about in class, just on a truck and not on a construction site. So we were able to kind of bring in these types of kind of interesting, and kind of, for us, it's more of an innovative way of bringing in some more mainstream understandings of materials, and then really thinking about what is being done here and how these material properties are being used, in this case to drive people to buy one vehicle versus the other. And then the last thing we did in terms of incremental changes too was that we increased the emphasis, again, due to some of the times that got freed up. We had the opportunity to include a little bit more content other than critical thinking. I put an asterisk here because it actually, we had to be very careful, and we did get a little carried away here. So we started emphasizing more statistics, data analysis. It's just kind of natural. We had a lot of graduate students helping us out. They were kind of doing their graduate research, so they wanted to bring that kind of knowledge in. And again, I put a little asterisk here because what I learned, this is just like a personal thing I've learned from the student evaluations, is that the more we thought, we had this additional time and we wanted to use it in an intuitive way, but what we ended up doing was kind of straying away from some of the lab learning objectives, which the students really caught on to. Statistics and things like that weren't really prerequisites for this class. So again, that asterisk is, again, just reminding us, even though we have this nice chunk of time or effort that we can kind of gain from going into these remote learning objectives, we still need to be kind of careful, at least on how we kind of balance out that time. So this one here is just really showing you, we've got in-person labs on the left-hand side, remote labs on the right-hand sides, and we were really just thinking about some of the advantages that come with each approach of lab. So I'll start off with the in-person lab advantages. So one, as I mentioned before, it was really that sensory feedback. Students and instructional team connect better with these materials, right? We have students that have never made concrete before, and regardless of all the safety issues we tell them, they just still put their hands in the concrete because they say, hey, I've never done this. I just wanted to, feel what concrete's like when it's wet, things like that. So there's this engaging sensory feedback that you're learning, that can be kind of hard to emulate in a remote session. Number two is the advantage is it also promotes teamwork and some of the other soft skills. These students are working in groups of 6. And not everybody is going to be able to do one thing, right? So it forces the whole entire team to kind of go into more of a industrial kind of what we do out in practice dynamics, right? We start seeing leaders emerge. We also see people that are really good at kind of the technical side of it. So it's really fun for us to kind of see these soft skills being developed due to kind of the teamwork and the group work aspect of the labs. And it's active, which is just another great component for people to get to know each other. We have high student engagement, just because it's very different from sitting in a lecture and listening and interacting with other students. Instruction team can also promote these soft skills. So I call it more of a it's kind of a ambient awareness of certain students. If we see students that are not really engaging very well or don't know quite how to maybe engage in a bigger group, we're there to also kind of coach them through some other soft skills that are going to benefit them in the long term as well. So these are all great things that we can really foster in-person labs, just because we're there and we can kind of see what's going on and read a lot of nonverbal information. And then one of my favorite advantages is that mistakes happen, and just like the industry, we actually love it when students make mistakes, because it allows them to really dig deep into kind of the lecture content to figure out how they can fix their lab. If students put way too much water in their concrete, let's say, that's not a problem, right? It happens out in the field a lot. So it's giving these students an opportunity to kind of react with problems that kind of arise. Moving on to the kind of the remote labs, the advantages there is it can accommodate more students per session. And this is what I think everybody have realized is space. And in some conditions, so geographic specificity and time is a little bit of a thing that kind of gets negated, right? So it doesn't really matter where you are, as long as you have connectivity and some of the technology, you can join into these remote labs. The time zone was a little bit tricky because there was still a live stream component of it, and we had people from pretty much around the world that could not make it back to the U.S., things like that, and they were able to join. Granted, it may have been 2 a.m. So that was another incremental change that we started talking about, is how we can allow students that are outside of our time zone to also be able to join in. Hence the asterisk there, with students can participate from anywhere. We also were able, since there was really no activities per se with their hands, we removed the potential for injuries, even though it didn't really happen. And the injuries that we were observing were like cuts and things like that. It was just nice to be able to have everybody not get injured in the remote labs. We also replaced physical activities with other learning experiences, so which meant that it was a form of kind of improved flexibility on how we offer these labs. And then lastly, we were able to reduce a lot of cost and waste. Traditionally, we're making a lot of samples, lots and lots of cylinders of concrete, and it's a lot of weight. And I penciled it out, and we were able to save about 70% of the material waste and the cost that we typically go through the in-person labs. It was cut down just because we're only doing it once, and in some cases we were reusing those same videos, so we actually didn't need to make new samples. So there was some cost savings and material waste kind of point of view as advantages of remote labs. In terms of disadvantages, I think the big one for the in-person lab is that due to the nature of the lab, the physical space capacity and the seats and things like that, there's a limitations on student enrollment. I can't have more than 24 people per lab, and we have 3 sections. So we can only have, in one quarter, around 70 to 75 students. And that was, even though we want to let more people in, it was just a physical limitation. Sticking on the in-person lab disadvantages, students have to commute to campus. So we are in Seattle, and it's a major city in Washington. And one thing there is we're kind of known as a commuter school. People can live outside of the city and they kind of commute in. So one of the disadvantages is it's very common for a lot of our students to have to kind of commute onto campus, which I'll come back to that idea in just a minute. Comfort level varies across students. This can be said is true with remote labs as well. Depending on the background and how comfortable these labs, they're not always appealing to students. They might not be so familiar with working with tools and things like that. So there's the comfort level varies, and we have to kind of gauge that again by looking at their kind of the nonverbal cues and things like that. And then number 4, the last one here is just, it was difficult to innovate because we had a set time. We had 2 hours per day. We had to get through a certain curriculum. So it became kind of difficult to innovate. As materials in our industry become more complex and go towards composites, we're starting to bring that into lecture because that's possible, but we found that pretty hard to bring in composites and newer innovative materials into our labs just because we had to go through some of the classic material too. Disadvantages for the remote lab: it can be difficult for our students to receive direct feedback from the instruction team. And this is what I was talking about earlier about kind of fostering soft skills. What we noticed, we encouraged having the video cameras on, but we didn't make it mandatory because we wanted to respect people's privacy. And what we kind of noticed is we had a high rate of cameras during lectures, but for some reason during these remote lab sessions, not many people were sharing their video screens, or their video cameras were not on. So it made it relatively hard for us to kind of determine whether or not the student on the other side of the screen, what they were going through. It was kind of hard for us to gauge that. And that kind of brings us to the decreased peripheral awareness depending on the remote meeting tool. Everything in Zoom, from what we understood, was kind of spotlit, except for kind of the gallery view. You get to see people, but when you're trying to bring attention, it's typically just 1 or 2 screens that pop up as a spotlight. So if we wanted to be looking at those things as well as the student, it was a technical kind of issue. It was harder to kind of see what everybody's was going through as we were disseminating some of this information. Now, this was more from a instructional team's perspective. So what we end up doing is we looked at some student evaluations from 2018, well before the pandemic, to the newest one we have, which is 2021. And what I specifically kind of pulled out here is a number of students that mentioned hands-on learning through labs contributed most of their learning. And traditionally, it looks like, in 2018, a good majority, like 83% of the students, mentioned how labs were helping them connect with the material and connect with the industry. 2019, somewhat similar, about 74% of the students mentioned that. Pandemic hit, and then we moved to the remote lab, and interestingly, now, we can't really conclude too much out of this, obviously, just because of the response rate here is relatively low compared to the beginning ones, but about 40 to 45% of the students from 2020 to 2021s mentioned the importance of labs. So we were starting to see this hands-on component kind of drop off. And one other thing, because these numbers were, I was really curious about what kind of made the change here, is what I learned was Discord. As a lot of you know, it's pretty much a great tool for anybody to connect with others online, and you can have all these different channels for different classes. And what I found out was that we had our juniors, seniors, and sophomores in some cases as well be part of this Discord channel. And some of the students from the 2019 cohort essentially was on Discord saying, man, you guys are going to miss out on the lab experience. So the idea of in-person lab was, I believe, still kind of in their heads in 2020 and even in 2021. So they're still kind of comparing it. So it would be interesting to see what would happen if we were to just keep, the remote lab going. I'd be kind of myself curious to see how these numbers would change as the perception of what the in-person lab starts to kind of fade away. Okay, just a few more things to cover here. Short-term changes that we were going to make to our construction materials lab. Most importantly, we don't want to lose this momentum for change. I'm actually already feeling this momentum for change kind of going away.
Sorry to butt in here. I mean, I know you got a lot of good stuff. We got 2 other panelists though we got to get to.
Okay, yeah, I apologize. So I guess I'll kind of cut it short right here. Just in terms of short term, don't want to lose the momentum. We also thought that the lab delivery method can vary depending on the need and the sensory feedback. So labs like concrete can be done in person, where metals lab could maybe done remotely. And then I'll kind of jump to the ahead here, long term. And one of the more important things was connecting us to the industry so we can take the labs out into the field. rather than trying to mimic it in the lab. But one of the more bigger things that I'm happy to start hearing in our own department, in our College of Engineering in general, is that this idea of blended learning is starting to happen, where we're contemplating the idea of offering bachelors in civil engineering totally remote. I think the last year kind of gave us a glimpse on what that might look like. And the labs were always the one thing that everybody had a hiccup on. Well, if they're not in Seattle, they might not be able to do the lab portion of it. And again, the last year, I think has started to kind of shift that perception of, maybe even the hands-on labs can be transitioned over to remote, and they're not going to lose so much of that content there. So I'm just happy to kind of start hearing more of these talks about and more faculty being open to this blended degree program where we can start offering more curriculum online. Clayton, I apologize for taking so much time. That's it for me. Thanks.
Well, thank you so much, Julian. And we'll definitely get back to you during the Q&A.
Sure.
Okay, our next speaker, Dr. Margot Vigeant. So, Margot, the floor is yours.
Thank you, Clay. Hello, everybody, and I'm really happy to be where I am in this session. And I don't mean by here. Take a moment. Appreciate this is the Susquehanna River. I'm at Bucknell University, which is on the Susquehanna River. I am not literally standing in the river right now, but just take it as your moment of peace. Breathe in, breathe out before we get to the slides. But being in this position, I think is really great because we heard from Julie and Carrie about the characteristics of positive and less positive online engineering learning experiences. And then Julian gave us a excellent example of a specific laboratories transition and the positives and negatives there. And so I'm going to do some inductive learning. I'm going to step back a click, and I'm going to kind of help us overall think about designing the future of laboratories, taking some of the lessons he was just talking about and abstracting them so we could all use them. So while I am a chemical engineer, this isn't necessarily chemical engineer focused. And we can hear me? My volume's okay? Okay, good. All right, so let's think about labs in general for a moment. I construct laboratories and engineering as part of active learning, right? We know active learning is really good and something we want to be involved in. I don't need you to read all or even most of what's on here. I've just got very faculty-centered on this side, going towards student-centered on that side. We have things like think, pair, share over here on close to faculty-centered. We have problem-based learning over there. And so labs are kind of inherently in this space, right? They're somewhere between doing things that are semi-student-centered to completely student-centered, depending on how you've set up how recipe-like a lab is. And also, they're very active all the time. It's kind of automatic. And they're also really rich learning environments. And thinking back to, in fact, reflecting on some of what we've just heard about, pretend I had a poll for you. Just meditate upon this for yourself. What actually is the point of hands-on lab? Like, what's your top 3 things you think engineering labs are doing for our students? And we have to believe, I think most of us, that hands-on was, before 2020, super critical because as we know, it takes a lot of space. It takes a lot of personnel. It is a big investment for us engineering programs relative to, say, the English department at our universities, that we have these hands-on labs. And in a study from 2005 that I think still holds up really well, Faisal and Rosa put forth 13 kind of canonical objectives for engineering laboratories. And you should see things here that maybe you came up with in your own brainstorming a moment ago, but the idea of developing sensory awareness of the lab is in there, working on your communication and teamwork is in there, comparing theory and practice is in there, designing and manipulating a system, and actually getting that, can you titrate? That's a physical skill That's all in here too. And I think when we were first faced in 2020 with the idea of suddenly doing emergency remote instruction, there was a lot of distress due to the fact that many of us who had been teaching labs hadn't actually gone through these objectives necessarily explicitly. Because we were hitting all of them all the time, we just knew that we could do that. But then switching to online, it's not so obvious that you can do this. And here I've grayed out some of them that are less easy to do online. For example, assembling a part might not be possible online, working on those psychomotor skills, developing sensory feedback. These things may work a little less well. So here is my idea. Labs are so good, in fact, at doing so many things that in many programs we'd gone years without examining this. I'll out my own program as this being the case. And in fact, I know it was the case for some other programs in chemical engineering, because chemical engineering does an annual survey about teaching classes. And when we did the lab survey, everyone said, oh yes, all those objectives are accomplished by my lab. And when we asked, okay, how many of those objectives do you assess? It was usually just like 1 or 2. We assess communication in the lab report. But the opportunity here is that the forced reconsideration of hands-on experiences as a result of the COVID crisis has given us the chance to make sure we're focusing on what's most important. And by doing that, in fact, as you have just seen in the previous talk, we may not actually want to use the exact same hands-on labs we were doing before. We may discover that we can better achieve some of our objectives by doing things that are online or more flexible. So I'm going to give you a few examples, not an exhaustive list of examples, but a few things that I thought were kind of neat additional interpretations of how to do lab in engineering while focusing on particular objectives in a way that really gets them to work at home. So, for example, at Bucknell University, my colleague Tom DeStefano and Monica Hoover moved their lab into videos. And their objective here was making sure the students were aware of the machinery and how it worked. You know, they had in the video, you see them pressing the buttons. But they recognized that in real life, most of the students didn't get a chance to touch the buttons anyway, right? There was only room for one person to do that. So that was something that they were willing to give up and double down on the data analysis. So then the students would receive the data and they would do their report and their teamwork and analysis as always. And so really data analysis and appropriate technical communication were the objectives that were underlined as the most important, while the rest, not all of the 13, but while many of the rest, for example, experimental design, were still present to some extent. Another example I want to share is from Dan Berkey, who is at University of Connecticut. And in their first year class, they have the students imagine they're building a Mars colony. And in this Mars colony that they're working on, there's fluid flow, right? You have to do air handling. And in that air handling, and this is what they do actually on campus. This is one of the challenges they might have on campus. A new thing they did for the at-home version, because they couldn't send equipment to everyone, was they challenged the students, come up with a way to measure a pressure difference in airflow using materials you have at home. So it was a design and build experience, very hands-on. And you can see here is an example. It's a tube from some wrapping paper with a plastic tubing from the aquarium filled with blue water. It's hanging on a set of doorknobs to hold it up. And to test it, they're blowing a hairdryer through the end. This captures perhaps better than what could have been done on campus, design and assemble and learn from failure and creativity as the students constructed something from scratch using what they had. Now, did it allow as much of a relationship between theory and practice as you might have had in the actual laboratory setting? No, a little bit less so, right? They don't have the measurement equipment like they would have. Who knows what the volumetric output of that hairdryer is? But they can certainly develop a qualitative sense. And I dare say their troubleshooting skills are perhaps better than they would have been otherwise. This example comes from Milo Koretsky, who was at Oregon State University and has now moved to Tufts, but this example is still at Oregon State. And this is something where the change happened prior to the COVID crisis, where there was a hands-on lab that they felt was not achieving its objectives sufficiently well. They switched to a simulation because it was better. So what is happening in this laboratory is the students are doing chemical vapor deposition. So it's a way you make computer chips. And that in real life involves some rather hazardous chemicals that you don't necessarily want undergraduates experiencing. It's not something you can really watch because we're talking putting a layer that is several molecules thick on top of a wafer. So that's not, it wasn't a highly interactive lab, and it's very expensive. So what did they do? They designed a realistic simulation, where you can see the machine and you have to go and interact with it. And what they emphasize here is experimental design. You have a budget, there's only so much you can do, you only have so much time, it takes a while to request a test and get it back. And in this, if you do good statistical design, you can test the parameters and come back with a good recommendation of how to make your chips just as well, in fact, if not better, than you could if they'd really done the experiment hands-on. So it really underlines this connection between theory and practice and experimental design in ways that just aren't accessible otherwise. And I've got one more example for you before we wrap up. Clark Hograff at RIT this last year in his controls class, so as for electrical and computer engineers, did a really nice at-home project. So every student was sent a control system with some motors and given instruction for how to make kind of a rudimentary system with this. And then the students, after they demonstrated it, were empowered and really, really well supported in each designing and building and troubleshooting and demonstrating their own control system. So using the motors that he sent out, you could make a ball balanced on a beam, but you could also make something that kind of tightrope walked. You could make something that kind of drew. You could make something that flung ping pong balls into a net. And the extent to which he was able to demonstrate students' additional time on task, additional engagement with the material, sense of self-efficacy at the end of the project relative to how it had been done in the lab where it was a little bit safer, is really impressive. I just look up this project. It's really cool. And one thing I want to say here is he also, as all these folks did, who I've just talked about, demonstrated a number of these good practices from our first talk. That is, no one does a successful control system as an undergraduate if you just get mailed it and graded at the end of the semester. There were lots of check-in points and lots of kind of mutual laboratory experiences, both asynchronous and synchronous, in support of all this. All right, so what did we learn? Alternate labs can hit objectives as well as their hands-on predecessors. Some of the objectives they can actually do better, And I'm not saying this is automatic or all the time that we should burn the lab down and get rid of it. I have to be very careful to say that because, you know, there's some people who'd like to recover that space. But no, I'm just saying by doing this nice focus on core objectives, sometimes we discover the best way to hit that objective isn't the way we've been doing it. And like Julian said at the end of his talk, I also want to say a number of schools are saying, oh, gee, let's keep things, let's not keep things. And a number of schools are saying, it's all bad, burn it down, let's go back to 2019. And so I really think I'd like us to consider holding on to some of the ways that these alternative presentations can be better. All right, thank you very much. That normal, there we go. Thank you.
Thank you very much. That I actually quite amazed with the technology there. I haven't seen that before, so I might have to bug you about that later. So thank you. And our next speaker to talk about labs will be Dr. Mark Miller. So go ahead and spotlight you here. So go ahead and take it away.
All right. Well, thank you, everyone. And thank you, Clay, for hosting us today and for everyone who's in attendance. So my name is Mark Miller. I'm an assistant professor of aerospace engineering at Penn State University, just down the road from Margot, actually. I also need to learn that Zoom trick. That was pretty neat. There's always new things to learn with Zoom, it appears. So today I'm going to be talking about sort of bucking the trend of what the other speakers have been talking about. I do have some discussion of lab course, but I actually don't teach our lab course here at Penn State Aero. But we did have some impacts for our student groups that I thought might be kind of interesting to chat about. So today I'm going to be talking about surprising benefits of remote and hybrid teaching when it comes to undergraduate engineering education. Let's see. So I guess it would help to give some context to this. Penn State kind of had I think, approach that a lot of larger universities took where they basically offered sort of every option on the menu as far as interacting with students. You know, the two that had any in-person components were obviously fully in-person or mixed mode. And then we also had several, I think probably the majority of our, especially in aerospace courses, were offered either remote synchronous or asynchronous. So I actually was the only faculty member that I know who offered a mixed mode or hybrid type approach to our introductory fluid dynamics course that we call Aerospace 311. We did have, and the reason I mentioned this is we actually only typically deal with juniors and seniors. So this group kind of has their own interesting mix of student experiences because of the way Penn State is structured. We have what's called a 2+2 system here. So we actually have 24 campuses, not individual universities, and the students don't transfer, but they come from all over the state. And I primarily deal with about 120 students in my course. And there were some unique challenges in getting this junior level course kind of into a coercive form and then making sure the learning format was kind of compatible and engaging with them. So I'll kind of talk about what worked and what didn't. And to give you some background, my research is in kind of wind energy and experimental fluid dynamics. So I really like to experiment with things, and I kind of took this as a little bit of a challenge to experiment with some different new learning methods. I'm not an expert in any of them, which is why this symposium is so interesting to me to kind of learn more about that. And I really like Jesse's description at the beginning of the session about this being kind of a catalyst. So, you know, kind of forcing us to rethink a lot of these things. And I only started this position in August 2019. So honestly, remote learning has been my normal now, as weird as that sounds. And so going back in the fall, I'm hoping to take some of these lessons with us. So I guess the thing I'll focus on today is mixed mode. Basically, the way it works is kind of the way you would think. We have a rotating student roster that comes in. I didn't actually require them to attend any lectures in person if they didn't feel comfortable. But from the instructor's perspective, it is a little more challenging because you're now, you know, as these arrows kind of try and indicate, you're now trying to manage two completely different groups that have different needs and different ways of communicating, and kind of different comfort levels also with how they communicate. So it's in some ways the worst of both worlds because you have to deal with these two completely different formats. But I think from the student's perspective, they're given the option of being stuck at home all the time or coming in even one day a week, which is what most of my students did. They really appreciated the kind of extra effort, even if it didn't always go very smoothly. Okay, so I'll just kind of scoot on through so we can have more Q&A session because I think that's helpful. So I noticed early on a lot of kind of side effects of working remotely that I'm sure many of you noticed, along with a lot of other ones. But the two key ones that I had trouble dealing with was very low student engagement when working, especially with the remote students, and also a much slower lecture pace. So this is Airspace 311 is a lecture-based course, and typically we deliver it, in person on a chalkboard. We also have like a digital tablet type devices that we use at Penn State. It's such a large class. And I just basically, this list on the right was all things that we tried. And I'll talk about kind of what worked and what didn't, but mini lectures the students really liked. And also some of these other kind of more simple approaches, such as adding more structure to the way the content is delivered, recording everything and making the content as accessible as possible to the students. And just a lot more prep work and increasing our kind of channels of communication. So I guess what I came out with was kind of three basically key things that the improvements fell under. The first one of those was giving the remote students a voice. At Penn State, they had this nice program they started during the pandemic, which was called Tech TAs. They're not really meant to help with course technical content. They're meant to help like basically as IT professionals and also as advocates for the students. So my tech TA, I told him interrupt me at any point, and he did interrupt me often, but it was good because he would bring, sometimes when you're dealing with both in person and remote, you just naturally tend to have a conversation on one, not the other, or maybe you step away from the microphone. All these kind of very small detailed things, and the tech TA kind of kept us on track there. So that was just one example of things that really helped. The other one I noticed that helped a lot, and this goes back to some of the questions that Jesse and Carrie asked, which I thought was very interesting, was, what do you think is most important when it comes to teaching remotely? And I noticed variety had a huge impact on student engagement. So this is just a screenshot. We talked a lot about, turbulent flows and how they become turbulent, what it means to be turbulent. So we incorporate a lot more media there. Obviously something that lends itself well to that. But this was kind of across the course, something that I usually would include this type of content, but we really increased that during the pandemic. And then structure, that was kind of the main takeaway, and just adding notes to the lectures. And I'll talk more about that on this slide. So normally our class, being the lecture course, is very rigid, very structured. And I tried to keep the organizational structure and improve upon that while not making the content itself super rigid. So we have to cover this content on this day. And we did get sidetracked a lot. But just making sure that stuff is available to the students as soon as possible, and that you're consistent in how you do things and when you're engaged. And I noticed a lot in our student feedback at the end of the semester that they really appreciated that. And we had pretty much no negative comments, which we have had in the past about, the frequency and timing of these things being available. We also came up with some new methods of content distribution, I would call it. I started calling them mini lectures. Like I said, if you have infinite time, and I think Julian mentioned this too, if you had infinite time, it would be great to just keep developing more content and new ways of engaging with the students, but you find out pretty quickly that it sucks up a lot of your time. But we came up with a few different mini lectures, and these basically kind of pre-recorded videos that the students could watch on their own time. I tried to make them short, pretty timely, pretty succinct, but also filled with comments from myself about, the slides would be pretty technical, but I'd kind of fill in the blanks in between. So it really was a lecture format. I think in the future, I'd like to incorporate more of those engagement, maybe polls or some kind of feedback mechanisms from the students. And what I kind of realized after all of this experience in reading into the literature, we're basically developing kind of half of a micro-credential almost in this course. We were doing the training, we needed to add kind of the evaluation step. And I think that's something I want to do and not really call it a micro credential, but almost a nano credential, something smaller than that even, where we, have a content, you watch the content, you deliver something related to that. It could be in a group setting or individually. We assess it and give them feedback. So instead of calling it a homework, right, it has kind of a more involved aspect to it. So I think that's something we're going to start incorporating in the future. And I sort of took inspiration. I know Clay and I have often talked about Mark Rober, which some of you may know, makes a lot of YouTube videos. And there's a lot of other good content generation out there. And that's kind of where this took inspiration from, is make it an informal conversation about a very technical topic and try to make it as relatable as possible. So I guess we'll just finish off this kind of with some quick results. I'm not going to go through everything on here, but really it is difficult to manage, and you do need significant extra preparation time. And especially with the students, I had special issues with the students on the fringes. My normal core group of high activity students, the ones that sit in the front of the classroom and that mural from the 1300s, those students were fine, right? It was the other ends of the bell curve that I was more worried about. We did have some comments. Interestingly, pretty much none of the feedback at the end of the semester was negative on all the things that we tried, and it did not always go well. Videos didn't work, demonstrations, I don't really have any of those here because they have student information in them, but those all went, even though they didn't go perfectly. I was really bad at camera angles. It turns out that's kind of a new skill I need, but they appreciated the effort. And I think that was kind of the biggest thing, that students noticed the effort, they appreciate it, and they appreciate it in normal circumstances, but it's also much easier to make an effort if you're all there in the same room together. It can be more difficult to do those things when you're all working remotely. And I guess lessons learned and things that I'm taking personally forward towards our this coming fall, which we are slated to go back to fully in person, is to kind of implement more of these and expand and kind of just continually improve the course instead of a complete starting from scratch when it comes there. And like Margot said, it's a good time to rethink some of the things that we kind of always just considered fixed before now. So I'll just end on this by saying, giving a plug for one of the student groups that I'm the PI and co-advisor for, which is our Wind Energy Club. They compete every year in the NREL DOE sponsored collegiate wind competition. They have a lot of hands-on projects. It's a lab-focused, lab-heavy, very applied project because they have to build a wind turbine. And the problem was Penn State didn't allow us any undergraduate in-person access to labs till this January. So we were really limited on them having any ability to build or do anything. And the competition did account for this, but the students kind of came up with a lot of creative solutions. They obviously moved everything to being held via Zoom, and we had much higher attendance than we did in past years. We also had a lot of additional training and technical seminars that the students would run. I ran a few of them myself on the aerodynamics side, which was also kind of fun. I took from our graduate courses and kind of pared down the material. We also had some of our alumni give presentations to our groups, which I thought was kind of a unique thing, and also helps with our knowledge retention long-term on the team. So something that, as a research group, we also struggle with is knowledge retention when students graduate. And I didn't realize kind of how close the needs of student clubs who work in the lab and research groups who work in the lab are. So I think actually I'm taking some of these lessons that the student and solutions the students came up with into our research lab to try and help with that problem, because training new students is just a continual challenge when it comes to labs of kind of any sort, but especially extracurricular and research type projects. So I guess I'll go ahead, kind of an end there. I just had a quick example of, some modifications that I actually made to our online course, which didn't need any because it was already fully remote. But we implemented a competition, which was kind of very well received based on some of the aspects of the wind energy group. And I guess the last thing I'll say as a plug to our Wind Energy Club, they obviously did a pretty good job because they took home first place this year in the competition. So we were pretty proud about that, especially considering almost every other team had access to their lab for the whole year. So I'll just end on that. And I guess thank you all for your time and attention. I guess we'll move to Q&A.
Thank you so much, Mark, and thank you to all of our speakers. So if we go ahead, I think I can get everybody spotlit here. what we'll do is, I believe there was a question asked that, and I know Margot, you had responded in the chat, but if you wanted to address that a little bit, it's a question regarding access to labs and gap amongst rich and poor institutions. Do you mind saying a word or two about that?
Sure, especially since my typed answer was mostly on the other part of the question. So there's different kinds of ways of interacting with a remote lab that emphasize different objectives. So I'm putting this slide up, and hopefully you can go to the video and hit pause and get a good look at it, and see kind of what the menu of what people have tested are. And it's a whole nother presentation that goes through how each of these maps to better and worse to different objectives, but you can probably figure it out. The way that this emphasizes inequities is some of these things are very expensive. Having students do laboratories at home is either expensive or at a baseline assumes they have access to certain materials, right? Like even the thing with the manometer made out of tubing, there's some stuff that folks just would not have. And so you really want to be sensitive to that. That's a reason it's quite nice to be able to send students materials. On the other hand, that costs the institution a lot of money. So that's not so great. Down at this end, we've got thought experiment. Thought experiment is what happens when I describe what's going on, maybe show you a graph. It's like what Mark was just showing us. We all could have just learned some things about airflow in what he was showing. And that is accessible to everybody, but we've given up some of the other objectives we might attain. So it is worth building equity into your thought process here for sure.
Thank you. Thank you. And then Mark had brought up a great point about this kind of hybrid activity, learning in the classroom and also learning remotely simultaneously. Julian or Margot, do you have any kind of experience or thought on that, especially with respect to a lab course? Because with a lecture course, it has its sort of flavor. Do you see this being a possibility with lab courses where you can have your students on campus or remote for that lab?
The instructional team in our lab specifically, we're kind of talking about where a few of our TAs actually come from a rural area of Washington, and it was very difficult for them to, join UW. It was a big hurdle to even get accepted in the first place. So we were kind of reflecting on that, and the answer is yes. We've kind of brainstormed. It was really interesting what Margot said about the approach of sending out materials to students throughout the nation or across the world. The problem is, with our type of material, that's over 200 pounds of stuff going through the mail, poor delivery person, right? So the other idea that we had is, well, we can start small, statewide first. So we'll just tackle state of Washington. There's some communities that may not be able, or that's just far away for reach from any colleges that are around that area. So what we can do is offer a lot of online content there. And then maybe we can just invest a weekend or even 1 week where we get a bus and we, or just some kind of a transportation and bring them to campus so they can experience the hands-on part as well. So there's a little bit of like that kind of talk that we were, it's very exciting to be a part of, is just kind of thinking about it from that perspective of more inclusion and diversity in our own curriculums without having to do much.
I believe here, in the interest of time, we should probably wrap this one up and get ready for our next session. So thank you again to Margot, Julian, and Mark for your time and your efforts here in putting this together. Really greatly appreciate it.